Hi, Year 8. So, in our first lesson in our new algorithms module, we're actually going backwards to recap what we've done in Year 7 in this module, where we learnt about how to write algorithms as flow diagrams. We already know the difference between algorithms, pseudocode, and programs, the three programming constructs, and how to create programs on RapidRouter that use those programming constructs. We also know how to translate block code to flow diagrams, and vice versa. We know how to translate flow diagrams to block code. There are three ways that we can write an algorithm. An algorithm is a set of step-by-step instructions that solve a problem. Regardless of whether it's a recipe for baking a cake, directions to the nearest restaurant or park, or putting together a Lego model. Algorithms are everywhere. But notice that algorithms aren't necessarily for computers. They're just sets of instructions. And there are three ways to write an algorithm. Number one, we can use flow diagrams to represent a set of instructions using standardized symbols and arrows. We can write them as pseudocode, and we can also write them as computer programs. Now, actually, we've already covered two of the three there. We know how to create flow diagrams. We created those last year. And we already know that we've been creating computer programs. We've created computer programs for our microbits, and even when we're on RapidRouter, they're still computer programs too. In this year's unit, we're going to learn about how to write pseudocode. Remember though that flow diagrams are where we use standard symbols to represent that algorithm. For example, this flow diagram will get the van to continue to move forward until it gets to its destination. The first thing it asks, though, is whether or not it is at its destination. The answer to that question is no, it would follow the instruction to move forward. It would then go back to asking itself whether or not it was at its destination. And it would just repeat this until the answer to that question is yes, which is when it would stop. Pseudocode is step-by-step written outline of instructions which can be translated to a computer programming language later. It sort of gives us a really nice way of writing down lists of instructions that look like computer programming, but without all that unnecessary syntax. There are some examples here. That's an example. But this is more like what we're going to produce in our lessons in this unit. All of this is to serve this purpose. It's for us to be able to create computer programs. And while we've been able to create computer programs using block code, we are yet to write computer programs using Python. Pseudocode, this is what we're going to be able to produce in this unit of work. So over the next few lessons, we're going to see, everyone's going to see code that looks like that. And we're going to be able to produce code that looks like that. But the reason we're doing that is because it's actually really, really close to Python programming that we can see here on the right-hand side. The reason we don't write this straight away is because, well, if in this Python code we forget to write that bracket or this dot here, it would mean that the code just wouldn't run. So this pseudocode, it gives us an opportunity to write code that looks very similar to that, but in a low stakes environment. We've got the same structure, the same indentations before instructions, just like they are here, but none of the syntactual detail that we have to go into for Python. Last year, remember, we talked about the three programming constructs. We talked about how programming is how you get computers to solve problems. We also talked about how computers are just robots that can only do what you tell them to do. And regardless of what it is that you get them to do, you can always get them to start repeating things because they never get bored at repeating. But we can also get them to make their own choices. All three of these put together are the three programming constructs. Doing things in sequence, which is running instructions one at a time and in order. Iteration, which is where we're repeating lines of code. And selection, which is where we are making choices. In our block code last year, we created programs that used selection and sequence and iteration. Over here, we can see on the left-hand side where we've used sequence. This is instructions one at a time and in order. These two are both iteration. One of them is a count controlled loop because there's a number involved, and another is a condition controlled loop because there is a condition involved. But we also talked about selection, how that's just asking questions which tells the computer what to do depending on whether a condition is true or false. For example, if you see a red light, you would stop. Otherwise, or else, you would go. Remember that we also did this when we created our night lights last year. We asked if the light level in the room was ever less than 50, and if so, we turned all the lights on. If not, we kept them off. And we did this in Rapid Router too, where we asked questions like if the road exists forwards or left or right, we would do a certain action based off of that. But we've learned about all these three programming constructs, from having to add instructions in order using sequence to counting instructions using a type of iteration called count controlled loops. We then use condition controlled loops to repeat more efficiently. And then using selection, we were able to use computers and their ability to use data from a sensor to solve every problem that we had.